Hello Khan Academy people, this is my second video, and in this short tutorial I would like to talk about pressure terms, because when we read physics, chemistry books, we mostly encounter terms such as absolute pressure. We also find terms such as atmospheric pressure, which is also called barometric pressure. And we also, there's also the gauge pressure and also the vacuum pressure. These all are pressure terms that we commonly find, and I would like to explain, the difference between these four terms. Well, I think we are all familiar with what pressure is. We all know that pressure is a force exerted over an area, and we also know that all fluids exert some pressure. And when I say fluids, we imagine gases such as air, and also liquids such as water in our oceans. Oceans. Now, we are also familiar with the pressure units. Many books use pascals. We also have bars, also atmospheres, pounds per square inch. And what about torrs? Torrs are also very common, and also inches of mercury. These are all units of pressure, And, well, let's talk about first of the absolute pressure. Okay, what is the absolute pressure? When we measure things, we usually use scales, right? Sometimes our scales have a minimum and they have a maximum, such as in exams, for example, you have the 0 as the minimum and 10 as maximum. Well, at least here in Mexico, a 10 means that you did that you got all answers correct, and 0 means that all of your answers were incorrect. So this type of scales tell us, how intense something is, right? So if we get a 5, we know that we are in the middle of a 0 to 10. So we can be average, let's say. But in some scales, we don't use maximums. Okay, so the maximums are not defined. Maybe when we talk about temperature, that the temperature, when we talk about kelvins, we know that the minimum is 0 kelvins, but we don't know what the maximum is. It can be infinity. We know that the sun is very hot, and maybe that's like 3,000 kelvins or something, but we know that there are things that can be hotter, so we don't actually define the maximum. So that's the same thing that happens with absolute pressure scales. So we define 0, which is the perfect vacuum, but we don't define the maximum. We know that there can be fluids that exert a lot of force, so there's going to be a very large pressure, but we don't define the maximum. We leave it to be infinity, as large as the system is. But we know that it can't be less than 0, because we do define the 0, and 0 is the perfect vacuum. So that's the absolute pressure. It can be a positive number, and it can be it can describe any system, and it's the most common used in formulas, in tables. So for example, when we talk about perfect gases and all those things, we use the absolute pressure. Okay, we use the absolute pressure, and we already know the units. Remember pascals, pounds per square inch, blah 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 blah. We all already know the units. But yeah, that's the pressure we use in formulas and in tables. And it's the most commonly used in the scientific community. So, if it's so common, then why do we need the atmospheric pressure or the barometric? And why do we need the gauge or the vacuum pressure? Well, basically the gauge and the vacuum pressure are relative pressures. They are defined depending on the atmospheric pressure. So let's talk first about the atmospheric pressure. Well, we all know that there's a big mass of air, okay, in the atmosphere, and it exerts a pressure on us, and that is called the atmospheric pressure. It's the pressure that the atmosphere itself exerts on us, and it's depending on the geographic zone you are, it's different. If you live in an island, at sea level, such as like me, then the atmospheric pressure is about 1 atmosphere, okay, if it's at sea level. But if you live, for example, let's say a mountain, okay, the atmospheric pressure will be lower than 1 atmosphere. Okay, it can be 0.9 atmospheres. But the higher you go, the lower the atmospheric pressure will be. So the gauge pressure tells us. So we already know that the atmospheric pressure is the absolute pressure of the atmosphere, only at the atmosphere. So the gauge pressure tells us how higher than atmospheric pressure we are. So for example, in systems like let's say a balloon or a tire, a car tire, sometimes the absolute pressure inside is higher than the atmospheric pressure. So if the atmospheric pressure is 1 atmosphere, the absolute pressure of the tire is 2.3 atmospheres. How higher we are than atmospheric pressure? Well, we are 1.3 atmospheres higher than the atmospheric pressure. So 1.3 atmosphere is the gauge pressure. Okay, so the gauge pressure tells us how higher we are than atmospheric pressure. We always need a reference point, which is the atmospheric pressure. And the same happens with the vacuum pressure. Okay, so the vacuum pressure is how lower we are than atmospheric pressure. So if you have, I don't know, let's say a container that the gases are consuming, then the pressure inside will be, will decrease. So here it will be lower than the atmospheric pressure around it. So if the absolute pressure of the tank is 0.7 atmospheres, then how lower is in the atmospheric pressure? Well, if we consider that atmospheric pressure is 1 atmosphere, then how lower we are? Well, we are 0.3 atmospheres lower. So this is the vacuum pressure, 0.3 atmospheres. So, remembering everything, we then define the gauge pressure to be the absolute pressure of the system minus the atmosphere. And because it's higher, the absolute pressure is higher than the atmosphere, then this will be a positive number. And the vacuum pressure will be the atmospheric pressure minus the absolute pressure of the system. And because the atmospheric pressure is higher, then this will also be a positive number. We use gauge pressures because they are easy to measure. It's easier to measure, things with a reference point such as atmosphere. So the atmosphere, so that's why the car tires, are measured in gauge pressures, So all types of pressures have their own applications. And one more important thing, the unit pounds per square inch, sometimes you can see with a G and sometimes you can see with an A. Well, the G represents gauge pressure and the A represents the absolute pressure. So thank you, Khan Academy people, for everything. I hope this cleared out many questions we had on the pressure terms. So see you.